We're now starting the Chapter 5 content on page 113. We're going to talk about shells for a little while. What is the shell actually? Well, you wouldn't be far off if you said, well, the shell is the command line, or at least the program that's processing the command line. That would be absolutely true. And you may recall our discussion before when we launch a terminal like this that you see. Remember, this is the GNOME terminal. I can prove that to you, right? Go to About. Yep, it's the GNOME terminal, as you see right here. That is running, but the terminal just provides something within which a shell can run. The shell that's actually running here is my default user shell. So how do you find out what your default user shell is? Well, you can use the cat command from before to look at this file. Oops, just like that. And this particular file has lots of settings, basically, that are used by Mint. So you see it starts there. And you see for the various users here what the default shell is. So the root user, the default shell is /bin/bash. And how about for me, I'm down here at the bottom, I'm Perry. And you see, here's my home directory, by the way, /home/Perry. And then here is my default shell, /bin/bash. So when I launch the terminal, it's going to load my default shell, which is the bash shell. Hopefully, you are using the bash shell. That is your default shell. You should check that if you're using a different distribution of Linux. If you're not using Mint or one of the Ubuntu type derivatives, you probably should check, see that it's the bash shell. It doesn't matter that much at this point. Most of what we're doing probably works in the other shells pretty much the same way. But as we start doing some bash shell scripting, there might be some things that will be a little specific to bash. So it'd be good for you to be using the same shell. And anyway, you can see what's there. There are some other shells installed on the system here. One of them is called dash, so I can take a look at that /bin/dash, and let's say dash L, so we get the details. So there is dash. Of course, bash we talked about is right there. There's another one defined, which is actually under Mint. It's the one that the system uses as its default shell, called sh, but you see that sh is actually just a symbolic link to dash. So the system is using the dash shell as its default when it needs a shell to run a shell script or something, or execute shell commands. For the user, the default is bash, which is just fine with us. And different shells, you can set different ones to be your default. In any distribution, just about. You can download other shells, like there's some mention of the C shell here. I don't think it's installed on Mint by default. It's at least not under /bin. But you can set different shells as your default shell. You can also launch any other shell that you want to, as long as you know where it lives, in order to accomplish different things. And different ones are good at different things, but bash is a great general shell. And very programmable as well, as we will see a little bit later in the course. So we have this shell that's running right here, and if I want to terminate the running of the shell, I can tell the shell that I'm done with it, and it will terminate itself. And the way that I do that, probably you've been clicking the Xbox up here, which closes the terminal, which will also terminate the shell. But to exit a little more gracefully, we exit the shell, and when we've exited the shell, the terminal knows it's no longer needed either because there's no running shell. And so it is kind of in a smarter order. So I type exit, and the shell goes away, and when the shell goes away, the terminal knows to go away. So I'll go ahead and start a terminal emulator session again, and when I start the terminal emulator, it starts my default shell within it. Okay, does that make sense? Now then, now that I'm within the shell at a command prompt, I could start another shell right here. In fact, I can start the dash shell if I want to. So I just say /bin/dash, that's an absolute address, and it runs that program. And I now have the prompt from the dash shell. and you'll see many of the things that you expect to work similarly in the dash shell. Notice here I don't have all the cool color and that kind of stuff that I have in bash. Dash is kind of used for certain other kinds of operations. Usually bash might be better. But now when I'm done working in the dash shell, I can type exit, and where did I go? I went back to the bash shell that owned the dash shell. So let's do that. Let's do that again. And let's look at the processes that are running. And you see here I have a process called bash and another process with the command dash, right? And then another process which is of course the PS. So this is similar to what you saw before, except now you see that there are two shells that are actually running here. And in fact, if I put a little more information up here, that's a little too much, right? How about, oops, up arrow doesn't work under dash. How about just PS forest? I don't want all that stuff. You can see the relationship between the processes. That is to say, the bash shell here is the parent of the dash shell, which is the parent of the PS command. Kind of cool, right? So what else can I do? How about we make another instance of the dash shell underneath this one? So /bin/dash, and whoops, up arrow doesn't work for that, right? So we'll say that again, and now you see that we have the bash shell, which has created a child process called the dash shell. This is its process ID, and it created a child process, which is another instance of the dash shell, and it created a child process, which is the PS command. Okay, so how then do we get back to the bash prompt? Well, we're going to have to exit this dash shell that's running, and then we're going to have to exit that dash shell that's running, right? So I can type exit. Doesn't look like anything happened, but I terminated one, type exit, and now I'm back to the bash shell. And so, whoops. And now you see just the bash and the PS command that I just executed. So hopefully that makes some sense. What we've done here is create shells from within shells, and often those are referred to as subshells. And we can say that they have a parent-child relationship. Just going back to my situation before, right here, the bash shell has a child shell called dash, and we would say that for this dash shell that I'm highlighting here, the bash shell is its parent shell. So parent-child relationships. And likewise then, I guess you could call this dash shell the grandchild of the bash shell if you like. And the PS command here would be the great-grandchild of the original bash shell if you like, or you could say it's a descendant of. And so there's a tree that represents the relationship between these, because this bash shell might also be able to create multiple child processes, not just one. We haven't seen how to do that yet, but that's coming here very soon. One command that I thought I'd mention at this point, I use it periodically, and I might have done it by accident without even thinking about it, so I thought I'd just point it out, even though it's not in the chapter. Sometimes you just want to get a clean piece of paper, right? And so if you type at the command prompt clear, you get a nice clean window like so. So another thing that you want to know about the command line is we can actually put our command line commands on a single line and then execute them sequentially. This is fairly trivial to do. We simply separate them with semicolons. So we do something like this. Let's say sleep for 3 seconds. You might not have seen that one yet. I don't remember if we've explored that yet, but we'll see it before long. Then ls, do something like that. You see I get a 3-second delay here before I get the rest of it. Now, this is actually just being executed in the shell that we're actually in. That is to say, there is no subshell being created. I can show that to you by adding one more command, which is echoing a certain environment variable. We'll talk about environment variables in the next chapter, but echo the environment variable bash subshell. And a 0 means no subshell. A 1 would mean that it's being executed within a subshell, the echo command. Okay, so I can actually create a subshell for these commands by putting them within parentheses, like you see here. And if I do that, I'm going to get the same output here, except at the end you see I get a 1 instead of a 0, meaning that bash subshell is true, essentially. In other words, that was executed in a subshell. So if I take a list of commands that are separated by semicolons and I put them within parentheses, they will be executed in a subshell. Now, how does this help me? Well, that really starts to become interesting when we start talking about background mode, as I'm about to show you. So now to start something in background mode, I'll simply add the ampersand to the end. Notice I get the output here for the first line and then here for the second. What is the advantage of that? Well, when I run something in background mode and create, in this case, I've created a separate shell and executed some commands in a separate shell, I'll end up getting the output back to the original shell, but the activity goes on in the background and it gives me the command prompt back. You see that I got a process number that says, okay, here's the process number for this new shell that's being created. And then it starts giving the output when it gives it to me, but I had the shell prompt back. I could have done anything else. This might be more clear with another example. Let me just use something a little simpler. How about let's sleep for 3,600 seconds. What do you say? How long is that? That's an hour, right? So if I just hit the enter key right now, I'm going to be waiting for an hour for this process to finish. Now, granted, it's not very exciting to start a sleep process. All it's going to do is wake up in an hour and say, oh, I'm finished, and then stop running. Okay, so this is not exciting. But think about any number of other activities that we might have. Let's say that you're going to process through a lot of files, searching for information or sorting or something like that, some activity that might take a long time to run. You don't want to be doing that and then just sitting here waiting for something to happen, right? You'd like to be able to move on to other things. So I'm going to hit Control-C. Okay, usually that is successful in sending a signal to terminate whatever is running. And now I'm going to do something else. I'm going to use the ampersand symbol to put that in the background. So now I have this 4024 process ID, right? And I ought to be able to see that. There it is. There's 4024. That's the sleep command. The PS command was running at the time the snapshot was taken, and there's my bash. But I can go ahead and do whatever else I want to do. In fact, I could make another one. Let's sleep for just 1,200 seconds, and we'll put that in the background too. And we see now that we have two processes running with the sleep command, right? So what shall we do? How about let's kill 4024 and 4027, and now we see that those are indeed terminated. So it shows you the last status change, and if you look at them again, you won't see them at all, right? So now those are gone. So using background mode is very valuable. And again, if we want to run shell commands, that is to say multiple shell commands in background mode, we'll create a background shell. We do that with the parentheses. Besides background mode, there's another way to make sure that a command is actually launched within a subshell, and that gives us some other options in terms of signaling, and that is to say that we can signal processes that are running inside the subshell from the parent shell, etc. And that can be very helpful. That's using a mechanism called coprocessing. There's some description of it on page 124, and you probably want to just glance through that so that you have some familiarity with it before moving on. So next I want to talk to you a little bit about built-in shell commands versus external commands. You may have noticed when I went through the example using the dash shell, many of the commands worked the same way, although the output might have looked a little bit different in one way or another, but they work pretty much the same way from one shell to the other. That's because some of these commands are actually internal to the shell and maybe specific to a particular shell. Some of them are external, externally provided. When you execute an external command, it creates a child process to run that command. So when I say that, you can already, just looking at the lines that are above my cursor, these two lines right here, you can tell already that the PS command is an external command. How do I know that? Because when it was running, it had its own process ID. Okay, so a child process was created in order to execute that command. Some of the commands, however, are actually built-in commands. So how do you know the difference between the two and what's going to produce a process or not? You can use the type command to find out what type of command it is. So CD, that's a shell built-in. What about PS? Well, we just found out it's not a shell built-in. It's actually external, and it tells you, you see, where it lives if it's external, right? So built-in versus built-in basically belongs to the shell. In other words, the bash shell, that program, knows how to execute that command and what to do. Obviously, if it's a built-in command, that means the behavior could be different from one shell type to another, and there could be different built-in commands. If it's external, then hopefully it's going to be a little more universal in the way that it behaves. One thing we've talked about a few times already is it's very convenient to go back through your command history by pressing the up arrow, and the down arrow you can go back the other way until you get to the empty command line where you just started. So you can go back through various commands, your last several commands. In fact, you can go quite a long ways that way. I think the default may be something like, I don't know, 1,000 commands or something like that. But you can see more than one at a time if you want by typing history, running the history command. And you can see I have a number of different commands that are in here right now. And I can scroll up through these and take a look at them. And you might think, oh, that's great. I ought to be able to copy and paste those things. Well, you can do better than that. If you have something like, how about this one, ps:/forest. You have a command that you want to execute. This is number 631. I can use the bang key, otherwise known as exclamation point, with that command number, and I execute that command. Now that's not a very interesting one to do, but how about one of these that's longer, like 639? So 639, and there. Now I'm running that whole line, whatever was entered before, and doing it with just a simple thing. If you just want to do the last command, it's double bang, like so. Why is that valuable? Because up arrow and down arrow are really handy when you're sitting at the keyboard, but depending upon the kind of connection you have and the capabilities of the terminal emulator that you have, if you're connecting remotely, your up arrows and down arrows may not function the way that you think they're supposed to and may not do what you want. So it's kind of good to have alternatives to up arrow and down arrow and at least know what they are. The next thing to discuss are aliases, and if you type the alias command, you'll find out what the aliases are that are built in already to your particular session. So these were provided for you to begin with, and I'll point out some of these are actually very helpful. The first one is anytime you type grep, look, it's adding the -- color equals auto. And you can look up in the man page what that does, but remember when we typed grep, it highlighted matches for us, so that was very handy. Same with egrep and fgrep, which are just variations. Take a look at these aliases here, though. I've got L, which is simply alias to ls-cf, and that's nice and short. Instead of 2 characters, you'll have to type 1. LA is an ls-a. Here's ls-alf. That's really handy. That's LL. And so let's take a look at at what those aliases do. Okay, these are really handy because there's this ls command, but here we've got different variations of ls that are alias to other things. So if I type just L, look at that, I get that. LL, I get that version right there. So instead of typing ls-alf, I can just type LL and get the exact same output. So it's nice to know what the aliases are. Even better, isn't it, to be able to list or to be able to add to the aliases. So maybe you want to create an alias for a command. In fact, I think that's one of the things I gave you in the assignment to do. Create an alias for a command, and the way that you do that is shown on page 132. So I'll leave that to your further study. And that takes us to the end of chapter 5. As we round the corner next week, we'll look at chapters 6, 7, and I think we ought to be able to get to 8 as well, managing file systems, although there I'm going to want you to skim the content, but not actually create partitions and do all the stuff that chapter 8 is indicating. So our real content's chapter 6 and 7 with a quick skim of 8, and then we'll be prepared to move forward from there. So have a good week, and take a look at the forum if you have any questions.